So welcome back to another video, and in this video we're going to be continuing on with our core data tutorial series. And in this particular tutorial we are going to be taking a look at how we can create relationships between entities, what relationship types are supported in core data, and how we can make utilizing core data in code a lot easier by handling optionality. So, first, let's talk about what kinds of relationships core data supports. Now, if you're familiar with relational database management systems, or RDMS, like MySQL or Postgres or even SQLite, you know that we can create relationships between different tables, and in this case, entities. Now, there are three different types of relationships that you can work with. There are one-to-many, which means one of something can have many of another thing, but only one of those many things can belong to something else. So an example of one-to-many might be a school can have many students, but a single student can only belong to one school at any given time. Or a school district can have many schools, but one school can belong to only one school district. Right? Something like that. The next kind of relationship is many to many. Now, many to many can be, for example, many books can have many genres, and many genres can belong to many books. So many of one thing can belong to many of another thing. And those many of another thing, something of that other thing can belong to many of the other. Another example would be each book can have many authors, and every author can have written many books. Things like that. And then the third kind of relationship is one-to-one. Now, one-to-one relationships are pretty much one thing can belong to only one of another thing, and vice versa. So an example might be, it's not a very practical example, but it's an example. One student can belong to one school, and one school can only ever have one student. Now, again, that particular example isn't a very practical one, but that is how a one-to-one relationship would work. So, what kind of relationship would projects and task items have? Now, I want you to pause the video here and give it a good think. I want you to think for a moment before I give you the answer. What kind of relationship would best fit projects and task items? All right, did you pause the video and think about it? I hope so, because when we're thinking about projects and task items, the best kind of relationship type here would be one-to-many, because a project could contain many task items, but one task item can only or should only ever belong to one project. So that is the best place. That's the best kind of way to think about that. If we were dealing with tags, right, and we wanted to apply tags to a project, that would be an example of a many-to-many relationship where each tag can have many projects and each project can have many tags, right? But we're not worrying about tags here. If you want to try adding tags to this project, you can absolutely do that. I urge you to give it a shot. For now, we're going to deal with one-to-many relationships. Now, how do we create those relationships, right? So inside of Xcode, inside of the core data editor, what I want you to do is first select the project entity. Now go into the relationships disclosure group, and inside of this disclosure group you'll find a table where this table has 3 columns. The first being the relationship name, the second being the destination type for the relationship, and then the type of, and then whatever the inverse relationship is. Now here we're going to select the plus button, and this relationship we're going to call tasks. So this is going to be the many side of the relationship because a project can have many tasks. Now the destination type isn't going to be project, but it's going to be task item. Now, we don't have an inverse yet, and we will do that here in a second. But what I want you to do is select the tasks relationship, and then go to your, the inspector. If it's not being shown, you'll have to show it. But inside of the inspector, you should find a relationship section when the relationship is selected. What I want you to do is I want you to find the delete rule. The first thing that we're going to do is we're going to change the delete rule. Now, there are a few different delete rules that we have here, so let's go through them. When we're dealing with relationships, the different delete rules are as follows. We have nullify, which means when, in this case, a project is deleted, the task items that are associated with that project don't get deleted along with it. They get, that relationship gets nullified. So the task items are just sitting there in no space, essentially. Not having a relationship with any project. That isn't ideal for this kind of relationship. At least, well, okay, let's back up. In some scenarios, you may want to have the delete rule be nullified in a one-to-many relationship, but in this particular scenario, it's not ideal. Because generally a task item should only belong to specific projects, and a lot of the time they're not universal, right? They don't apply to every kind of project you can create. So a different rule would be better. The second delete rule that we have is cascade. Now, cascade is a better delete rule for this case. The cascade rule essentially says when we delete a project, delete all of its associated task items. Delete anything that's related to the project in this particular relationship. So in this case, task items. If it were, if it were something else, then it would delete that whatever other entity it might be. Deny pretty much says, well, we can't delete this project unless everything that is associated with it is deleted first. So it will deny your ability to delete this parent entity unless all of its children are deleted first. And then we have no action, which when we try to delete a parent entity, and the delete action is, or the delete rule rather is no action, it won't do anything. No action will actually be taken. It's not very common that you'll use no action. I never use it, but it's there if the case scenario arises where you do need to use it. Deny is actually used more often than no action, although I have never used deny either. It is there if you need it, though. So let's go ahead and set the delete rule here to cascade. And then for type, it has to one by default here, but that's not what we want. We want to many. So now core data knows that this is the many side of the relationship. And what this will do internally is when Xcode builds our code and all of that sort of stuff, what it will do is it will create classes for us that we can't see, but it will create classes for us for each of our entities, and those classes will have properties relating, directly to our attributes and relationships inside of our entities. When one side of it, or both sides of it, or whatever, are set to be too many as its relationship type, Xcode will interpret that as an NS set. This is yet another instance where core data shows its age, because we didn't have the Swift set type back in Objective-C. We had NS set. So NS set is what it uses here. You can't directly modify this set, the NS set. So it also generates some different methods for us that allows us to add and remove items from that NS set whenever we need to. And we will be using that at a later point when we show how to create data inside of our core data store. So with that is how we can configure the many side of our relationship. What about the one side? Well, let's go ahead and do that. We'll say task item. We'll go into the relationships disclosure group for our task item entity. We can see our empty table here. Go ahead and add a relationship. And this relationship is going to be called project. So this is, again, going to be the one side of our relationship. And because the to one side is also, much like the to many side of our relationship had to one set by default, this one also does. So we don't have to change that. And the delete rule is set to nullify by default, like it was for the task items side of the relationship. So we can keep that as well. The only thing that we need to change is the destination and the inverse. So for the destination of our project relationship, it'll be project. And then the inverse will be tasks. Now, when we do that, we've automatically set the inverse for both of our sides of the relationship. Because when you set the inverse of a relationship on one side, Xcode sees that and says, oh, okay, there's a relationship here. Let me set the inverse of the other side of the relationship for you, And that's exactly what it did. All right, so with that, that is how we can create our relationships in our core data editor. The next thing that we need to do is we need to create some extensions to help us handle optionality. But before we do that, I want to explain to you how we handle optionals in Swift compared to core data, because they are not the same thing. So when you create an attribute on an entity, you can mark it as optional in the core data inspector. But that does not mean that it's not going to be optional or not optional in the Swift code. When core data refers to an optional, it means, does the underlying core data store, the persistent store, does that require a value to be present by the time the persistent store has changes committed to it? So when we call save on our managed object context, by default, core data expects that by the time that save method is called, there is a value associated with each attribute. But if you mark it as optional, an optional attribute, using the optional checkbox in the inspector, then it won't. You can override that behavior that way. So doing that is entirely up to you. I tend to leave it alone unless I absolutely have to, if my program requirements call for it. Otherwise, I just leave it be. So that is there. Now, regardless, core data, when it creates those classes for you, when Xcode does that, everything will be an optional, in like a Swift optional. So because of that, we would have to do a whole bunch of nil coalescing or unwrapping throughout our code, and that just looks ugly, right? It just doesn't look good. So we can create extensions to help alleviate that problem. Let's go ahead and actually do that. So what we're going to do is, first, I'm going to create a new folder. We're going to new folder, and we're going to call this extensions. And then inside of this extensions folder, I'm going to create a new file, and I'm going to call this project plus core data helper. All right, so here we are inside of our Swift file here. I'm going to import foundation. And then I'm also going to remove the comments up there because it's not relevant. And then we're going to create an extension on project. Now, project is the class that Xcode creates for us. Extension. So here we are. We've created an extension. If we jump to definition of our project, we can't jump to its definition because Xcode doesn't allow us to jump to the definition of a class that it creates for us behind the scenes, which is unfortunate. You can change that to where it'll generate the files for you and place them in your project so you can edit them. But honestly, I wouldn't. I would leave it alone unless you absolutely have to have something that you can edit manually. It's usually best to just leave it be and let Xcode generate it for you behind the scenes. Inside of this extension, the first thing that we want to do is create a computed property for our project's name that will handle all of the nil coalescing for us when retrieving the value. But this computed property is going to do more than just retrieve the name of the project and then return a default value if it's nil. We're also going to allow it to set the name property of our project. So to achieve this, we're going to use get and set accessors, which is a Swift feature that is very useful. If you're familiar with C#, these work pretty much exactly the same. So inside of our extension, we'll say var project name string, and we'll say set name equals new value, and then get, we will return name, and then if it's nil, we will say unnamed. All right, cool. Next we're going to have a computed property for the ID. So we'll say var project ID of type UUID, set ID equals new value, get ID, otherwise a UUID, like that. After our ID, we can say var expected close date get or set rather expected close date equals new value, or rather project expected close date and then we'll say get expected close date, and if that's nil, we'll say now. So whatever the current date is. Next, we'll say var project created at date set created at equals new value, and get, we'll say created at, and if that's nil, we will say dot now. And then var project last modified date set last modified at equals new value, and then get will be last modified at, and if that's nil, it'll be dot now. And then we'll add just at the end of that as well. So with that, we can also double check just to make sure. So if we focus on our project here, so we have one for created at, we have one for expected close date, ID, last modified at, and name. So we're good for our project entities extension. You might be thinking, well, wait a second. We still have is closed. We still have the Boolean. And that's true. However, Booleans, integers, doubles, and floats, they do not get set to nil. Or rather, they're not optional, I guess would be the best way to say that. They're not optional. They get set to their own default values within core data. So, for example, Booleans are, I believe, false by default. Integers are 0, doubles are 0, and floats are also 0. I believe decimals aren't non-optional, so they are optional, I believe. Don't quote me on that because I rarely use decimal myself. But that's besides the point. Now, let's take a look at task item so we know what we need for that. So we'll need computed properties for created at and last modified at, expected completion date, the ID, and the title. So let's go ahead and go to our extensions, and we'll create a new extension. A new empty file. We'll say task item plus core data helper. We'll delete the comments. Import foundation. And then we'll say extension task item, like that. Okay. Now we will create all of our computed properties for the task item. We'll say var task item ID, which is going to be a UUID, set it'll be ID equals new value, get is going to be ID, and if that's nil, we will return a UUID. Next is the title for the task item, so we'll say var task item title, which will be a string. We will say set title equals new value, get title, and if that's nil, it'll be untitled that gets returned by default. Next, we're going to have the expected completion date. So var task item expected completion date we'll say set expected completion date is equal to a new value, like that. Get we want to return expected completion date. Otherwise, if that's nil, we will return the current date. You could also return distant future if you wanted to, but we'll return the current date just because. What you return there is entirely up to you. And then now we will create computed properties for created at and last modified at. Var task item created at date set created at is equal to new value, and then get created at, and if that's nil, we will return now, so the current date. Var task item last modified at date set created at, or not created at, last modified at equals new value, get, and then for the getter, we will simply return last modified at, and if that is nil, we will return now. Perfect. So that is the bare bones of what we need to do. However, the NS set for the many side of our relationship is also nil. Or rather, not so much nil, but it's optional. Now, when you're retrieving, for example, all the task items related to a project, you don't want to unwrap that, right? You want to make sure that you have at least something, even if it's an empty array. So what we can do is in our project extension, Okay, Xcode. If you could not have multiple editors open, that would be great. Okay, there we go. So the last computed property that we need will only get something. It'll only return something, so we don't need to use accessors in this one. And we'll say var project tasks. This will return an array of task items. And follow this very carefully because this is very specific. We want to return tasks. So inside of the auto completion, you can also, you can see exactly what I said. It is an NS set. It's an optional NS set. Now, all NS sets have a property called all objects. And this is going to be an array of any. However, because our set is optional, when we call all objects, the result of that will also be optional. So what we need to do is we need to cast this. So we need to optionally cast this as an array of task item. And if this is nil, if this expression evaluates to nil, we want to simply return an empty array. So let's go back over what the statement we just wrote does. So we are returning our tasks NS set dot all objects. So it's an array of any, and we are attempting to cast it to an array of task items. If that can't be done for whatever reason and it's nil, we return simply an empty array. So we don't have to worry about unwrapping it or anything like that. And of course, if it isn't nil, we will return that non-optional array of task items. All right, so that is how we can get all of the tasks in the many side of our relationship while handling all of the optionality and whatnot. Now, we don't do the one side of the relationship primarily because there's no realistic way to do it. So we just leave that alone, and we deal with unwrapping it as necessary in our code. All right, so that is how we can create our relationships between entities, what kinds of deletion rules there are, the kinds of relationships that we can use, and how we can set up our project to allow us to work with the core data just that much easier without having to worry about all the optionality, just having all of that encapsulated in an extension for each entity. Thank you all so very much for watching, and we will see you in the next video.